Hello students, myself Sanjay Singh, Government Engineering College Ajmer. Today we will learn the demultiplexing of address database in 8085. As we know uh, in last lecture that there are three types of buses: address bus, data bus and control bus. Address bus is of 16-bit of length, data bus is of 8-bit of length and control bus that is used to carry 1 bit of control information. Address bus is a unidirectional bus that is used to carry the address. This is 16-bit bus. Other bus is data bus. Data bus is a 8-bit bus and this data bus is multiplexed with uh, LSP 8-bit of data bus is multiplexed with the address bus. The address bus is range from A0 to A15 and data bus is uh, from D0 to D7. The address bus A0 to A7 is multiplexed with data bus D0 to D7 and it is pronounced as AD0 to AD7. This bus is bidirectional bus. That means this bus is used to carry the data from microprocessor to memory and peripherals and vice versa. It means this bus serves both the functions of address as well as data. At the same time, during the execution of instruction, these lines carry the address bits during the early part of the execution and then during the later part of the execution, they will carry the data of 8-bit. Data it may be data or it may be opcode, but in later part this bus will carry the required data or opcode of the bus. In order to separate these address from data, we can use a latch to save the value before the function of bits changed. Here is the diagram that how we will mm, separate or demultiplex these address and data buses. But before we have to demultiplex or these data and address lines, first we have to understand what is the need of demultiplexing. For that, we have to show the timing diagram that this is the timing diagram of opcode phase cycle of the microprocessor. In opcode phase cycle, opcode phase means first operation of any instruction is always opcode phase in which the opcode of the instruction is read from the memory and that opcode is given to the microprocessor instruction decoder and execution section, and that section that we have like this the instruction opcode is come from the memory and stored in the instruction register and then instruction from instruction register instruction decoder. So in the early part of the execution, this bus that is called address multiplexed address data bus means this bus performs both the functions of addressing and data. Means this bus carry address as well as data. Then when the bus will uh, carry the address information and when the it will carry the data. As we show in the diagram, timing diagram, in T1T state, in T1T state, higher order address bus will always carry the higher byte of the address. That is, for example, address is 2005H. Then 20 is the higher byte of the address and 05 is the lower byte of the address. So higher order address bus always carry the higher order of the address and lower multiplexed address data bus that is lower order address that will carry the address during the early part of the um, opcode fetch, and in later part, that is from T2 state, it will carry the opcode or the data. So how the data and address are differentiate? It is differentiate from a signal that is called ALE signal, that is address latch enable. As name suggests, when this signal is enable, address latch enable. When this signal is enable in address data bus, the address will be carried. And when this signal goes low, here, when the signal goes low, this multiplexed address data bus will carry, means this bus will be in high impedance state, and now it is switched for a data bus. So when the signal goes low, the address information will be latched and data will be traveled through this bus. तो डाटा कहाँ से आएगा? When read signal will be lower in T2 state, that informs the uh, address database that now the data is available for transmission, and the data will be copied from this. Now see this diagram. This is called the latching diagram, or how to demultiplex the address database. Here we see in higher order address bus, always the address will be flow, and in lower order multiplexed address database, when ALE signal is high, the lower order address will be flow from this side, and when ALE signal goes low, like this, when ALE signal is goes low, the uh, this latching diagram, this latch 74LS 373, that is called the latch, and this latch will be goes off. When ALE signal goes low, then this latch will be goes low, and it will be disabled. Disable means no information will be flow from this side. If no information flow from this side, then where the information will be go, or the data from this side will be go. So there is no path to follow from this side. Now this flow, now the every information or the data will be flow from this side, and this side it will works as a data bus. So when ALE signal is enable, means goes high, the this circuit will be perform, uh, will be enabled, and whatever the data or address will be carried from this side will flow from that side. When this signal goes low, this circuit will be closed, and the information will be flow from this side. This is how the address and data bus will be differentiate or demultiplexed. If we don't demultiplex this address and data bus, then what happens? For example, there is a address of 2000H in program counter. So 2005 is the address. If we don't demultiplex, then next data is 4F. Now program counter will be increment every time when there is next instruction to be executed, and if it is incremented, it will be goes to 2050, that is invalid address, as we know, because the next address to be executed should be 2006H. So that's why we have to demultiplex the address and data from each other. I think mm, you learned the how to demultiplex the address and data bus. Thank you. so much.